Now I want to understand from the machine perspective, can machines be endowed with consciousness? When shall we say a machine we call is conscious? Is there a test of consciousness? This is the area which we might not address today, but it's one of the areas which we will like to address.
This is a marvelous question, Vijay, because it was touched on really deeply by one of the great scientists working in the field of consciousness, who is the great mathematical physicist Roger Penrose. And he wrote a book in the 1980s. And at the beginning of the book, the supercomputer is being unveiled and switched on. And the emperor says, "Now who would like to ask the first question?" And then you have the book. And at the end, in the epilogue, the next scene is given. And the emperor says, he has said, "The little boy in the front row, why don't you ask the first question?" And it becomes clear that the little boy has asked the question, "What's it like to be a computer?" The question never appears in the book. But the emperor is saying, I don't think the computer can answer that question. And when you read one of the approaches to defining consciousness, which is now very popular, it stems from a great scientific paper written by a philosopher called Thomas Nagel in the 1970s. What is it like to be a bat? Yes. And Nagel essentially pinpoints one of the things which Deepak also pinpointed in his introduction. We all know what it's like to be ourselves. We can wonder what it might be like.
But I don't know what is it like to be a woman.
No.
Myself, I don't
know.
What goes in one's
mind. And I don't know what it's like to be Vijay.
Yes.
But I know what it's like to be Alex. Yes. And each conscious being knows what it's like to be themselves. And when we take our mobiles or our cameras or our video cameras, they can record everything. Speech, sound, you name it. Could even record the smells and the tastes. But they don't know what it's like to be a video camera.
No, this question Alan Turing has answered, or some people, philosophers answered differently.
Yes.
When we talked about machine to be intelligent. So first we say, what do you mean by intelligence? The question is that, machines, a human can calculate, they have computing power of computation, and machines had powers of computation, and then over the years, machines had tremendous computation, they exceeded the computational power, computability of humans several years back. And today, humans cannot match as calculating or computability power of machines, isn't it? Cannot match. Now, when came something else, no, this is not the thing. And then they said another challenge, can computers play games? Humans can play games. And they said, which game you want to say? So they said, okay, we'll take chess as a game. And chess is, of course, a very intelligent game. And then say, can computers play chess? And they say, okay, we'll write programs. And the people, I think many computer scientists or people who took that challenge and wrote programs by which they achieved, at least the supercomputers have achieved the capability of exceeding the chess playing capability of grandmasters.
Garry Kasparov.
This was done. I said, but then they said, no, there is not that. Can computers do this? Speech recognition. So this is a shifting. What is that? You are not sure. You will say that whatever is done, whatever is you accomplished, then you say that is not intelligence. Beyond that, can they understand natural language? And then they achieved some capability of natural language. And then everything was done. And now people are asking the question, no, can computers have emotions? Can they have affection? That capability of affection. And now there is MIT lab, that affective computing labs, that computers can laugh. Can computers, now the issue of can computers understand jokes or humor, for that matter? So this, when you achieve one particular capability, we are asking, can you do this? Can you do that? Can you do that? Can you do that? We are not sure. The question came, then people asked the question. No, that is after all, humans program the computers. After they are not done themselves, the programming of themselves. Then the question comes, how are you sure that you are not being programmed by somebody else? Humans are machines which have been programmed by somebody else. This one. Then the question comes, they are silicon machines, but we now machines of silicon, inert matter, or something like material, and we are biological structures. But tomorrow's computers will be biological also. We are developing computers which are biological computers, biomolecular computers. So this issue is that we are not sure. The question that whether we are machines or we are something else, and whether we are programmed ourselves or we are programming ourselves. So these issues are still philosophical, coming into philosophical domain, that whether humans can have machines can have conscious abilities, and we'll discuss that issue further. But this is the issue which is coming now for the frontier in the discussion of computer science as well. So what has been your explorations on this from the physics perspective or some other perspective?
The wonderful thing that Deepak mentioned earlier is this idea of being self-referential. And the question arises, how do you put something self-referential into the physics? Yeah. And you find when you succeed in this, which is something that this topic will range onto later, that you can actually build into physics, or you find emerging from the physics, the concept of a self-referential system. And when you ask yourself, where do you find it in biology? You find it in the brain, and there are many papers about this self-referential property, not calling it that, calling it another technical name. And they say it's present throughout the cortex. Yeah. And then they say it's present throughout the physiology. And then they say it's present even in single cells. So what you've been pointing to, Deepak, is that this innately self-referential property, which you have come to the conclusion has to be at the center of consciousness, and which the Vedic Shastras, the Vedic sciences, say is definitely at the center of consciousness, the biologists are now seeing in the form, though they don't yet know it, that our work has discovered in the physics. So I think that there's a tremendous unity. The question is, how do you put that self-referential property into your computer systems?
Yeah, I must say that, that Butterfly discussed this issue of cybernetic systems.
Yes.
While studying both the mechanical systems, the machine systems, as well as the biological systems. And when he talked about feedback and feed forward, would you refer to a feedback system, a cybernetic system, a feed forward system as a self-referential system?
Indeed. So these things have the beginning elements of what is needed to create a conscious experience, possibly. But when you look at what is actually going on in the cell, you find that it's not just one system, it's all those systems integrating together. And it turns out to be in, as far as we can tell, the genetic networks. It's in the deepest structure of the cell, in the deepest regulatory processes, and the way these switching processes are interconnected with each other. There was an absolutely marvelous biologist whose work I think we must come back to, who was one of the inventors and discoverers of complexity theory, Stuart Kauffman. And Kauffman's work must be gone into in a lot of detail, because he was the person who actually managed to see these self-referential systems. Though he may not have realized it at the time, he saw the fruits of the self-referential systems when he was actually first investigating genetic networks as a graduate student. A really amazing fact. And he was doing it through computational analysis and using computers to try and simulate what was going on in genetic networks. And he came to the conclusion that there was a particular condition which would only that condition could make the genetic networks work properly. And it was a condition that turns out to have a self-referential property at the heart of it.
I think, Deepak, I want to ask you the question. You said that you want to explore cell fundamentally, like cell biology, something we are talking about. Now you are brain science, brain surgeon, or you are studying, you are experimenting with brain. So do you think that, is there a brain in the cell?
If you could go back one step about when you asked Professor Hankey about intelligence, I'd like to share one very interesting thought. We had an exam for neurosurgery where we passed, it was called as a grand viva, which was where all the examiners got together and they grilled the student about different, it could be history of neurosurgery, it could be current advances, it could be whatever. So one of the professors in my grand viva asked me, how do you define intelligence? Because that is one thing we have to, we call that as examination of higher functions. That means intelligence. So we have the intelligence quotient, you have different yardsticks. And anyway, I had done pretty well in my exam, so I thought, let this be a jazz kind of an approach to giving an answer rather than a classical approach. So I said, in my opinion, intelligence is adaptation.
Brilliant.
So
Brilliant.
He said, what do you mean? I said, if I consider myself to be intelligence, this has an evolutionary basis also, this answer, because when we talk of survival of the fittest, we are talking of the program that is there in a particular species. The ones who can adapt to any changed circumstances are the ones who are going to survive, and those who cannot adapt are going to perish. So the ability to adapt, in my opinion, is real, what is in the true sense of the word intelligence. It is an ability to adapt. And when we redefine I would like to probably set the ball rolling in this aspect, that we have to be very clear in our understanding that if we are going to try to look at consciousness or intelligence from a very limited perspective, as in saying that if it's like if tomorrow we were to take the corollary forward, that if you were saying that we now want the computer to play chess. If I were to say that I will consider the computer to be intelligent only if it can climb a tree. Now, that does not make sense to me, because then I am defining the parameters and I am saying that only if you do this, it's called as a conditional understanding of intelligence, of consciousness or intelligence. Intelligence and consciousness, I think, are something which are more universal. And I think this fact was borne out by the very famous double-slit experiment, where even a photon was considered to be conscious as well as intelligent, because it probably changed the way, and instead of simultaneously passing through both the holes, when there was a camera kept at the screen, it decided that it is going to go through one slit. So at a photon, which is like at a microscopic level also, that particle, so-called inanimate particle, is also besieged with intelligence as well as consciousness. So maybe we will have to redefine our parameters of understanding and concluding that only if these are the criteria that are met, then we would be handing out, or we would be condescending enough to assign consciousness to a particular object.
I think we are coming now with these dilemmas which is coming from Turing time, that machine is intelligence if you can do these things. And I think Turing test, there is nothing like Turing test, that in the sense of so profound Turing test. But this definition of adaptive systems we are talking about comes in control systems.
Yes.
I have designed, we know that we have control systems and we have adaptive control systems. So they are mechanical systems or electronic systems which are adaptive to the environment, adaptive to inputs, in certain sense, in a restrictive sense. Then question is adaptive. Before that will come, can computers learn? Do they have learning ability of the environment? Learning ability of the environment, adapting ability of the environment. Do the systems have their own, can they understand a language of their own, or can they create a language of their own? There are several questions will come. This question, while defining consciousness, will also come. If I suppose you say the consciousness means this, and I really mimic that function on a machine, or I simulate the function, then is it the question will be, is that the machine conscious then? Then you say, no, not this. Then you should be able to to do that, something else. So, do you think at the end of a discussion we'll say we're able to come, a system is conscious or self-referential, whatever we call it, conscious, so even of itself, if this is accomplished? Will you be able to come to that definition or understanding?
This is a very, very profound question. I think these questions come down to one thing which was put out very clearly about 20 years ago by the philosopher David Chalmers, who has been the father of all consciousness studies for the last 20 years. And what he said is that we know that mechanical systems have been able to mimic functions of consciousness, and biological properties of biological systems may explain functions of consciousness. But consciousness, as you call it, awareness on the deep inside, is more than just functions. And as you rightly said, Deepak, it's a self-referral property. Now, it seems that to have an awareness in a space of awareness is something which is unique about consciousness. How is that possible? Chalmers says that the fact of actual animation of subjective awareness, being animate, is something which is going to have to be taken as a given in the universe. The universe contains matter. We understand mass. We now know, due to Einstein, who you mentioned, that mass is equivalent to energy. There is electric charge. There are other quantum numbers associated with elementary particles. All these things are fundamental in physics. We're going to have to introduce, Chalmers says, some thing in itself, consciousness,
Thing in
or
itself.
awareness, a thing, well, it's not a thing,
Yeah.
but it's going to be an entity being,
Attribute.
an entity, not an attribute,
Entity.
a raw entity like a raw electron, or a field, or mass. We're going to have to introduce this and then see how this emerges in its complex form that we experience in life. How does it actually come to be in the universe? But we're going to have to take this concept as absolutely fundamental. This feeling, this inner core of experience, we're going to have to say is inexplicable, and we have to introduce it as an entity.